Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Today we are going to solve the numerical problem for chapter number 10, waves and oscillations. So first we solve the numerical problem 10.1. The statement of the problem is the time period of a simple pendulum is 2 seconds. So the time period of the simple pendulum is 2 seconds. This is given. What will be its length? Now we are going to find the length on the earth and the length on the moon. So first we write the given data. In this problem, we have the time period of a simple pendulum, which is 2 seconds, and the gravity acceleration due to gravity on Earth, that is 10 meter per second square, and the gravity on Moon, that is 6 times less than the gravity on Earth. It means this is equal to 10 divided by 6. So when we divide 10 by 6, we get 1.67 meter per second square. So these are the given data, and now we are find length on Earth. What will be the value of length on Earth and the length on Moon? We know the relation or formula used in this equation or this problem is the time period of a simple pendulum is equal to 2 pi under root L over G. Now solution. Now we are going to find first the length on Earth. So from given formula we simplified. T is equal to 2 pi L over G. So for the time period or for the length on Earth, we use a subscript E. So the time period, so when we find this LE, so for this taking square root on both sides, so after taking square root on both sides, we get T square is equal to 4 pi square LE over GE. From this we just solve for LE. So we get LE is equal to gravity on Earth into T square divided by 4 pi square. So putting the values, we get length on Earth is equal to G is 10 meter per second square and the time period is 2 seconds divided by 4 into 3.14 whole square. So the value of length on Earth after calculating this is 1.02 meter. So this is the length. So this is the length on simple pendulum on earth. Now dear students, we are find the length on moon. Again we use the formula for time period of a simple pendulum. T is equal to 2 pi L over G. So here we use the subscript m, small m for moon. This is the length of moon and the gravity on the surface of the moon. Again for Lm, taking square root on both sides and simplify the above equation, we get Lm is equal to Gm into T square divided by 4 pi square. Putting the values of Gm and time period and pi, we get Lm is equal to 1.67 meter per second square into 2 second whole square divided by 4 into 3.14 whole square. So we get the length on the moon is, which is equal to 0.17 meter. So we find both the values of the length on moon as well as on the surface of the earth. Okay, now we are solving the second problem of this chapter. The statement of the second problem is a pendulum of length. Now in this numerical, the length is given, is taken to the moon by an astronaut, the period of the pendulum, and also given the time period of a simple pendulum, which is what is the value of G on the surface of the moon. So first, the given data is the length on the surface of the moon is 0.99 meter. So the length is given. Also the time period of the simple pendulum is 4.9 seconds. So what is the value of the G? So to find value of G is equal to 1. So we solve for G. So we know the formula which is used in this numerical is T is equal to 2 pi L over G. T is equal to 2 pi L over G. Now we solve this. So we know that by squaring, taking square on both sides, so we solve this equation for G. So we get G is equal to 4 pi square L over G, L over T square. So G is equal to 4 pi square L over T square. We just replacing after. First we take the square on both sides and then just change the place of G with T. Putting the values, we get G is equal to 4 pi square is 3.14 square, length is 0.99 meter divided by T square, which is equal to 4.9 second. So when we divide this, we get the answer 1.63 and the unit for G is meter per second square. So in this problem, we just find the value of G on the surface of moon. Okay, students. Now the numerical problem 10.3. So in this problem, the statement is find the time period. So he asked for the time period of a simple pendulum whose length is 1 meter. This is most important numerical and is FBISC 2021 paper. This is in FBISC 2021 paper. Placed on the earth and moon, the value of G on the surface of the moon is 1/6 of its value on the earth, and the value of G on the surface of the earth is 10 meter per second square. So given data in this problem is the length is 1 meter of a simple pendulum and the value of G on the surface of the on the earth is 10 meter per second square, and the value of G on the surface of the moon is 6 times less than on the surface of earth. So that is equal to, we can also prove this in last numerical, 1.67 meter per second square. Now we can find time period of the simple pendulum. So the time period of the simple pendulum when it's placed on the surface of earth. So TE is equal to 2 pi L over G. So for TE we use a subscript E for surface of the earth, G on the surface of earth. So after putting the values, we get TE is equal to 2 into 3.14, L is 1 meter and G is 10 meter per second square. So after calculating this, we get the time period on the surface of the earth for 1 meter length is 2 seconds. This is the time period of the earth. So this is the time period on the surface of the earth, and now we calculate the time period on the surface of the moon as well. We use the same formula, just we use a subscript M for the surface of the moon. So the length is same, but the acceleration due to gravity is changed. So after putting the values, we get T M is equal to 2 into 3.14, L is 1 meter and GM is 1.67 meter per second square. So after calculating these values, we get TM, which is equal to 4.9 seconds. So we get both the answer, the time period on the surface of moon and the time period on the surface of the earth. Now the last question of the 10.4 is solved by the formula T is equal to 2 pi L over G, solved by the formula of the time period of a simple pendulum. And after 10.4, that means from 10.5 to 10.10, these are all problems solved by the relation V is equal to Fm. So in this question, we have a statement like a simple pendulum completes one vibration in 2 seconds. Calculate its length when G is 10 point. So the given data is The given data is the time period of a simple pendulum, which is equal to 2 seconds. So t is equal to 2s, and the value of g on the surface of the moon is 10 meter per second square. Now we are going to find the length of a simple pendulum. So we use the formula of the time period of a simple pendulum, which is equal to t is equal to 2 pi L over g. So for a, we square the both side of the above equation, so we get t square is equal to 4 pi square L over g. So for L we get g t square divided by 4 pi square. Putting the values, we get g is 10 meter per second square and time is 2 second square divided by 4 pi means 3.14 square. So we get the length of the simple pendulum for which the time period is 2 seconds, and that is equal to 1.02 meter. So this is the length of a simple pendulum, and the length of a simple pendulum is 1.02. So these are the numerical problem which are solved by the expression t is equal to 2 pi L over g. From about 10.5 to 10.10, these numerical problem are solved by the relation v is equal to f lambda. So students, the homework is repeat or solve these questions in your notebook. Okay dear students, Allah Hafiz, take care.